A very good morning to one and all present here. Myself Krishnaraj. I am working as assistant professor in the Department of Computer Science and Engineering in St. Joseph Institute of Technology. Today I am going to talk about introduction topic from computer architecture. So functional units of computer systems. So functional units of computer systems, these plays a vital role in the area of how the information will be processed and how it will get executed to get the desired output for the users. So there are so many components responsible for performing these operations. When you talk about a computer system, there are the essential components are input output unit, memory unit and arithmetic logic unit, control unit. So input output unit which performs normal input output operation, and memory unit which talk about basic storage, how the data has been stored and how it has been stored in the computer system. When you talk about this arithmetic logic unit and control unit, this is the brain of the computer. What are the instructions given to the computer? This ALU, arithmetic logic unit, which performs basic arithmetic and logical operations, and this control unit which plays a vital role for the execution of information. This control unit is nothing but how it controls the computer instructions. So for example, if the user is providing input instruction to the computer, so this control unit which will helps to recognize that this is the input instructions received from the user. So we need to carry this input to the memory and we need to store it. So likewise it will control the computer, and moreover this control unit performs what kind of operation need to be performed. It decide what kind of operation to be performed, like input, or you need to perform arithmetic logic operation, or you need to perform output operation. So it identify the operation and it will inform the CPU. So this is this very important unit in the place of CPU unit. So when you talk about the functional units of computer, input output unit, memory unit, ALU and control unit. So ALU and control units comprises will be called as the CPU, nothing but the processor. So this will be the brain of the computer. So when you talk about the input units, so there are so many input peripherals are there. So input units consist of so many input peripherals like keyboard, mouse, then scanners, then joystick, then webcam. So many input devices or input peripherals are there. When you talk about output unit, so what the output unit will do means it will provide a desired output to the user in terms of displaying the output in the screen, or in terms of output in the form of printed format. So likewise it will get the output. So there are so many output peripherals are there, like a monitor, then printer, then speakers, etc. So these are some output devices. And when you talk about memory, so there are so many memory units available. So main is primary and secondary memory, we will see in the further topic. And when you talk about arithmetic logic and control units, so these are the important components which is available in the central process unit. And so another important topic, another important concept when you talk about the memory part is, as I already told, memory unit can be divided into primary and secondary memory. So we'll call as RAM and ROM. So RAM stands for random access memory and ROM stands for read only memory. So when you talk about random access memory, it will be a volatile, and when you talk about ROM, it will be non-volatile. So volatile in the sense when the power gets shut down or due to any technical issues happened in the computer, the data will get lost. So that is RAM. So RAM is volatile. The data will get lost once any power failures occurs. When you talk about ROM, it is non-volatile. Even though any kind of power failure occurs, the data can be retained. And when you talk about the second point, data will get lost, and here data won't be lost at the time of power failure. Then RAM memory will be called as a temporary memory and ROM will be called as a permanent memory. And next one is RAM is we are using for both read and write operations. ROM we are using for only read only operations. Okay, so this is all about the basic units, basic functional units of the computer system. So in the further topic we will be see about the classification of memory and how many types of memory available in the computer system based on its speed, based on its storage, which will get more efficient. We will see in the next topic. Next we are going to talk about memory and memory hierarchy. So memory plays a vital role in the place of storing data and instruction in order to get a clear and successful execution of the programs, user inputs. So here we are going to talk about the different memory hierarchy. So we can see here CPU registers, cache memory, main memory, magnetic disk, magnetic tape, and optical disk, etc. So there are so many there is so many memory available when you take a computer system. So when I am going to talk about this, when I am going to talk about hierarchy of memory, so we can classify this hierarchy of memory into two main classification. So first three, that is CPU registers, cache and main memory, or the internal memory. When you talk about magnetic disk, magnetic tape, then you can say optical also you can add optical disk. So optical disk, so these three, magnetic disk, magnetic tape and optical disk, these three memory constitute external memory. So internal memories are normally inbuilt with the motherboard of the computer. When you take a CPU register, normally the CPU register is a kind of memory, very high speed memory, which is available inside the CPU, inside the microprocessor itself. And cache memory, we have another memory which will capable of forwarding the instructions received from main memory to the CPU. So CPU are very high speed and this is capable of executing millions of instructions per second. So main memory is not much faster when compared to the CPU. So in order to avoid that, we have we have an intermediate memory, cache memory, which will carry the which will faster than the main memory, which will take the data, which will receive the data from which will receive the instruction from main memory and will send to the CPU for execution. And when you talk about the third one, main memory will be called as a RAM, random access memory. It's also temporary memory, and whichever the instructions which will bring for the execution with the CPU, first of all it comes to the main memory only. Okay, so main memory, then cache memory, then finally it resides in the CPU registers for execution. So CPU register, cache memory and main memory, these three memory will be called as internal memories, since it is resided in the motherboard of the computer. And next three memories, you can see magnetic disk, magnetic tape and optical disk. These three memories will be constituted as external memory. So when you talk about external memory, which is resided outside the motherboard, okay, when you talk about magnetic tape, there is a separate slot for that. Then optical disk, you have separate drive for that. Then you will be having magnetic disk, that is also you will be having separate slot for holding this kind of memory. Okay, so these three memories are what for storing high volume of data, high storage, and these three memories will be called as what permanent memory as well. So I am just going to classify. Next I am going to compare these memory hierarchy in terms of two parameters. One is in terms of storage, second in terms of speed. So memory normally measured by the performance can be measured by the memory in terms of two parameters. One is storage and another one is speed. Okay, so I am just going to put an arrow. First of all, I am just going to measure the storage, on what basis the storage. Okay, so when you talk about the storage of this memory hierarchy, will be having first CPU register, cache memory, main memory, magnetic disk, magnetic tape, optical, the communication, etc. Okay, so when you talk about this memory hierarchy, when you talk about the storage capacity will be increases from top to bottom. Okay, storage of this memory hierarchy will be increases from top to bottom. Storage increases. So storage increases from top to bottom. In the sense, CPU registers are very less storage. Cache memories are also is a lesser. These are the least storage devices. Then these are lesser storage, and main memory is less storage. When you compare these external memory, these are higher storage. Okay, so storage size increases from top to bottom. Okay, increases from top to bottom. So CPU registers are less, then cache memory, then main memory, then magnetic, then magnetic tape, optical, likewise it will be going on. Next parameter I am going to talk about speed. When you talk about speed, the speed increases from bottom to top. Speed increases from bottom to so when you talk about the speed, second important performance parameter of the memory, talk about the speed, it increases from bottom to top. So bottom to top means bottommost memory is optical disk. So optical disk are the less storage, less speed, then magnetic tape, then magnetic disk. So these are all the less speed when compared to the internal memories. Okay, so external memories are high storage but less speed, and the internal memories are high speed and less storage. So main memory is high speed memory, then cache memory is higher than the main memory, and the CPU registers are the topmost speed when you talk about the transfer of instructions. Okay, transferring of instructions from one place to another, that is from main memory, from memory to CPU, or from CPU to memory. So the data transfer speed is high when you talk about CPU registers. Okay, so that's why when you are going to buy a microprocessor, we will be normally talk about the clock speed. So how far the data will be, how far the instructions will be transferred from memory to processor and processor back to memory. So how then only we will be get the user response as quick as possible. So that's what we are normally preferring clock speed when you are going to buy a microprocessor. So CPU registers plays a main role. So normally we know about only hard disk, floppy disk, pen drive, these are the storage devices. So we won't bother about what is happening inside the motherboard. So inside the motherboard there are so many memories. So likewise main memory, cache and CPU registers. Okay, so this all these are the these entire things will be constitute the memory hierarchy. Okay, so next I am just going to take another important topic about what are the memories available in the CPU, especially CPU, and how the communication between memory and processor are happening. So this diagram, I think this diagram is visible for you. So this diagram which will be called as the communication between memory and the processor. So for communicating from one part to another part, we need an interface normally. So in processor and memory also there is a proper interfaces available. So that interfaces will be called as a bus. Okay, so this bus which providing interface between main memory to the different parts in the CPU. So you know already I told that CPU register. So apart from CPU register, we have so many things available. So apart from you studied here only CPU register. So within CPU register you have so many registers available. So makes how it improves the speed of the processor. So that's the thing we are going to take it out. So communication between memory and processor constitute two layers. First one main memory, second one is CPU. Okay, so this part is main memory, this part is CPU. So we are providing a proper interface here. This interface will be you can see the interface here. So one is unidirectional, and these two are bidirectional. So unidirectional, we are telling that this is the address bus. Okay. Next we will see about the different registers available in the CPU. So in main memory, in the CPU, we have MAR, that is memory address register, then PC, the program counter, IR, that's instruction register. And when I talk about this regarding data, we have memory data register, then we have some general purpose registers. We have a wide range of general purpose registers starting from R0, R1, etc. up to Rn-1. And next we have control and ALE unit available. So this is generally control and ALE unit available. So now we are just talking about the memory registers available in the CPU part. Okay. So I'm just telling once again. So normally a communication between memory and the processor, normally communicated via different interfaces. We will be called the interfaces as bus. So bus is nothing but the collection of wires. So this unidirectional we will be called as address bus, bidirectional we will be called as data bus, and this bidirectional bus which is used for carrying the control signals. So this is directly connected to the control unit, so it will carry control signals to different parts of the computer. Okay. So next to that, in the part of address registers, we have memory address register. What is the purpose of memory address register? Means it will store the address of the instructions currently executing instructions. It will store it, and program counter. So program counter will be stores the address of the next instructions to be waited or next instruction to be executed. So that will be stored in the place of program counter. An instruction register consists of the instructions to be executed. So these three completely dealing with address. And next one, this is the data register. Data MDR. MDR stands for memory data register. This normally we are storing the data, which data is currently in execution. So it stores the data need to be executed. And general purpose register is also used for storing the data to be executed, data to be executed. So these are all about the communication between memory and the processor, or you can call it memory and the CPU. Okay. So next we are going to talk about some basic operational concepts. So when you talk about basic operational concepts, we need to talk about instructions. Okay. So instructions are nothing but the computation techniques we need to give to perform a particular task. Okay. So instructions are nothing but the information we are providing to the CPU in order to perform a particular task. For example, if you want to perform addition operation, means you need to pass addition, you need to call addition function followed by what are the values you want to add. So, okay. So you need to perform, that is the operation, will be called as addition operation. So that is the instructions, that kind of instruction we need to give to the CPU. Okay. So we have some set of principles whenever you are giving input to the CPU. You need to make the CPU to be understandable. Okay. So the instructions should be some specific protocol you need to be followed for the instruction. So basic operation concepts will teach you about how the CPU instructions will be there, and what will be the format of how you need to give a CPU instruction so that you will be make the CPU to execute a task in a successful manner. So instruction can be classified into two types. Now CPU instruction can be classified into two types. One is operation code, shortly will be called as opcode, and second one is operand. Okay. So first one is operation code, and second one is operand. Okay. So normally how we are performing, in the programming languages we will be called as what is the operation you are doing. So like function. Function is the utility you are going to perform. For example, sum, then find the power of, then find the log of. So this is the operation you are going to perform. That is the opcode. and operand is nothing but what are the variables you are going to make it, right. For example, you are going to find the power of 2 means the power value you need to give for the 2. So, the power will be normally a variable, any kind of dynamic values you are giving to find 2 power 3, 2 power 4 like that. So, likewise operand you have to give. So, CPU instructions can be classified into operation code, operands, and so this is the op code, shortly will be called as op code, and this is operand, okay, maybe single or plural, operand or operands. Example, typically I can give an example, add location comma or not, add location comma or not. So, add here, add is the operation code, okay, this is the operation. So, this is the op code, add is op code, and LOCA, okay, it is a location, LOCA is a location, this is an operand, LOCA is an operand, comma or not is an operand, okay. So, we are using 2 operands, location and or not, okay. So, add is the opcode, okay. So, in order to perform this simple CPU instruction, this is collectively called a CPU instruction, okay. This CPU instructions can be performed, okay, by 4 different steps, okay. So, in order to perform this single CPU instructions, you need to carry 4 CPU instructions, you have 4 steps you have to be follow. So, example, these are the steps you have to be follow. First one, fetch the instruction. Before the arrival of instructions to the CPU, normally where the instructions available, the instructions available in the main memory itself, okay. So, whenever the program or whenever you are going to do some computation in the CPU, first of all the instructions need to be bring into the main memory, okay. So, from that main memory it will traverse, from the main memory it will traverse to the CPU part. So, this is a CPU part. So, wherever you want to store, okay. So, it will becomes resided and it will be perform the operation, okay. So, first steps, fetch the instruction, fetch the given instructions from the main memory to the processor, okay, that is the first step. Fetch the instruction, the entire instruction, add local comma or not into the CPU, that is processor. Second one, fetch the operand, locate from main memory into the processor. So, what is the operand? So, a location is especially a named place of in the memory, okay. So, in memory there is a one place. So, that place is called as a location. So, in memory, in location there is one operand place, okay. So, you have to fetch the operand, okay, maybe a data, maybe address, whatever it is. So, location you have to fetch the operand from the location, okay, from the main memory and into the processor. So, that is the second one, fetch the operand at a location from main memory into the processor. So, first you have to bring the entire instruction from main memory to the CPU, then second one, fetch the operand from location and bring it to the processor. Third one is add. What is the opcode we are using? Add. So, okay, so add instruction, it will add the location, operand value of the location with the value in the register, general purpose register, as I already told, R0, okay. So, it is a general purpose register. So, some value we will be giving in the R0. So, what is the value available in the R0? That value, so this it will be added with R0, okay. So, add is a opcode, add the value of location operand with R0, okay. So, you will be get one addition value, no. So, the final one is you have to store the result, okay. So, where you have to store the result means add the location value, okay, with the R0 and you have to store in the CPU register itself. That means you have to store in the R0 itself, okay. So, for performing a simple operation, for performing a simple CPU instruction, add local, add LOCA comma R0, we need to follow this 4 steps, okay. So, this is all about the basic operational concepts, okay. And these are the instruction, these are the information need to be followed while executing a single instructions. So, my next topic I am just going to talk about 8 ideas in computer architecture. So, there are some key aspects. So, what are the things has been fulfilled in the place of computer architecture? What are the techniques beyond the building the computer architecture? So, all those things will be things built on these 8 important ideas. So, The 8 important ideas are Moore's law, second one abstract design, third one performance through parallelism, fourth one make the common case first, then fifth one performance through pipelining, sixth one performance via prediction, seventh one hierarchy of memories, and final one is dependability via redundancy. So these are the important key aspects. Okay, so let's discuss about one by one. First one, Moore's law. So Moore's law is Moore's law is one of the inventor, and he contributed his maximum in the place of building and designing integrated circuits, and he is one of the co-founder of Intel Corporation in 1965. So what his idea is, so whenever the cost required to build or manufacture or fabricate the integrated circuits, example for microprocessor, manufacturing microprocessor or microcontroller, whatever it is. So every year the cost of manufacturing the integrated circuits will be doubled in every year. So as per his philosophy, Moore's law, he stated that for every year the cost will be doubled, the manufacturing cost of the integrated circuits will be doubled for every year. Second one, abstract design. So when you talk about abstract design, the entire architectural design has been classified into two types. One is low level design and another one is a high level design. For a user perspective, when the user is going to buy a IC or a processor, he won't be interested to know about the low level design. He will be focused on only the high level design. The low level design is nothing but how the program has been done in the place of how the program has been done in the place of the motherboard, and how the program has been done in the place of circuits, etc. The high level design means we are only talking about the performance. What about the clock speed, what about the storage, and what about the cost of the particular device, etc. So those things will be considered as the high horizon. So in abstract design, which will highlighting only the high level design and ignoring the low level design to the users. So that is called as a abstract design. And third one is performance through parallelism. Parallelism is nothing but the CPU is capable of executing instructions simultaneously. If more than one task is performing simultaneously, parallelly, we will be called as a parallelism. So the computer architecture need to be built on the basis of parallelism. Okay, so next one is making the common case fact. Making the common case fact means in order to execute a particular instruction, all the components in the computer need to be cooperated. So all the components need to be integrated to form the successful output. So in order to perform a particular CPU operation, all these components like input unit, control unit, ALE unit, output unit, all the need to be performed. So that is called as a common case first. So making the common case first, which tells about each and every, for a single instruction to be executed, what are the components required, all the components need to be ready for that execution. Fifth one, performance through pipelining. In pipelining is a technique in computer architecture. It makes the CPU or processor to execute tasks simultaneously. Okay, so when we can say a CPU is a best CPU or a good performance means when the CPU which comes to perform multitask at a time. So that is called as a pipelining. Then next one is performance via prediction. When talk about the CPU via performance via prediction means CPU is capable of executing the instructions in the clock cycle. So in some cases some clock cycles will be already fixed to execute the instructions. In order to avoid that, in order to avoid the wastage of clock cycle, some CPU has its own intelligence that for executing this particular instruction only this much of cycle is enough, so that we will be able to avoid the wastage of remaining clock cycles. So performance via prediction is capable of a CPU or processor for avoiding the wastage of clock cycle while executing the instructions. Next one, hierarchy of memories. So as I already told, hierarchy of memories. Hierarchy memories, we will be having so many list of memories available. So in terms of internal and external memories, we have so many classification of memories available, and based on its storage, based on its speed, etc. We will be able to classify the memory. So memory hierarchy plays a main role, and what kind of memory you have to give to the system to get a good performance. And last one is dependability via redundancy. So the computer system should be dependent on redundancy. So why we are going for redundancy means in order to access the data, even though any power failure or any kind of technical failures occur in the computer system, so this technique will be capable of retaining the data or getting the backup of the data. So that is called as a dependability via redundancy. So redundancy, how redundancy make possible in the computer system means by creating multiple copies of data and in the storage, so that even though one drive failures, so we will be able to retain the data from the other drives. Or nowadays we are using we are using cloud storage for backing up the data, etc. So for handling long volume of data, we will be using what? We will be using cloud for getting backup of the data and all those things. So dependability via redundancy means we are storing the data in multiple forms. We are storing the data in multiple storage, so that any kind of technical or power failures occurs, we will be able to retain the data in future. So these are all about the important key ideas in computer architecture. Thank you.